Assalamualaikum warahmatullahi wabarakatuh. The topic is radioactivity. Let us look at the definition of radioactivity. Radioactivity is a random and spontaneous decay process. A random and spontaneous decay process of unstable nucleus by emitting radioactive radiation. So from here we can understand that the nucleus is not stable. So how to make it stable? It needs to emit radiation so that it will become more stable. So that is something that we need to understand why decay process happens. And then there are three types of radiation here. You can see here the first one is alpha particle, then beta particle and gamma particle, gamma ray. So you can look here, these are the symbol of the alpha, beta and gamma. So and here you can see here, I draw this to show you what is the meaning of this symbol. So this is proton and this is neutron. So you need to recall we have neutron and proton in the nucleus of an atom. Okay, so let us look at the first example. This is uranium-238. Okay, this is the nucleus. So actually there are many more neutron and proton in the nucleus, but I just draw this to show you a group of proton and neutron. But actually this is not the real number of proton and neutron. So we just look at the number here in order to know what is the actual number of proton and neutron in uranium-238. So when uranium-238 goes through process of decay, okay, it will be changed to thorium. You can see here from uranium it becomes thorium. At the same time, alpha particle is released from uranium. So let us look at the number of proton. Initially it is 92. Now it becomes 90 after the process of decay. So means here there are two protons here. Okay, you can see here there is no more proton because the proton has been released in the alpha particle over here. Okay, you see that? And then here is the neutron. Okay, now you can see there is no more neutron here because the neutron has been released in alpha particle or the helium nucleus. So that is why you can see here the number has decreased. You can see the difference because alpha particle has been released. Let us look at the second example. This is thorium. Okay, thorium. The thorium also goes through process of decay. Now look at the number of proton and also number of neutron. Initially it is 190 proton. Okay, so as we know, neutron is made up of proton and electron. So you can see here, let us take one example here. We have one neutron here. Okay, the neutron here will split into proton and electron. So what happens is there's no more neutron here. Okay, there's no more neutron. But we have another proton here. because it has been split. The neutron has been split to neutron. And okay, let me show it to you. So the neutron here is here, and the electron is here. So electron is what we call beta particle. So that is why you can see here the number of proton has increased. Initially it is 190, now becomes 191. And then the number of neutron has decreased. 144, now it becomes 143. So I hope you understand from this explanation. And the last one, we are going to look at cobalt. So cobalt, the proton number is 27, and the number of neutron is 33. So in this process, you can see that there is no change in number of proton and also number of neutron. This is because the ray here is massless. Okay, it doesn't have any mass, but it has energy. So this process produces energy. So that is what we should understand from process of radioactivity and radioactive decay.